It was a paradise. For over 160 million years, dinosaurs ruled a world of towering forests, endless coastlines, and skies filled with flying reptiles the size of small aircraft. Tyrannosaurus rex, the apex predator of its age, hunted with senses honed by eons of evolution. They never saw it coming. In the time it takes you to blink, everything changed. The Mesozoic era. To call it a golden age would be an understatement. This was Earth's longest-running biological experiment, a world where life had grown large, diverse, and unstoppable. Forests were open canopies of conifers and ferns, with flowering plants just beginning their rise. Dinosaurs weren't merely surviving, they were thriving. From the frozen poles to the steamy equator, they dominated every niche. But beneath this paradise, deep in the void of space, something ancient and indifferent was approaching. It was between 10 and 15 kilometers across, roughly the size of Mount Everest. It had been wandering the solar system for billions of years, and on one ordinary spring day, 66 million years ago, its path intersected with ours. It entered at approximately 64,000 kilometers per hour. The atmosphere couldn't stop it. Nothing could. The Chicxulub impact. Named after a nearby Mexican town, this was no ordinary collision. The asteroid struck a geologically unique region, shallow waters rich in sulfur-bearing gypsum. The energy released was equivalent to 100 million megatons of TNT. To put that in perspective, the most powerful nuclear weapon ever built by humans was 50 megatons. This was millions of times more powerful. Within seconds, everything within line of sight was incinerated. A magnitude 10.1 earthquake shook the planet. Tsunamis hundreds of meters high surged across oceans. But this was just the beginning. The impact threw 25 trillion metric tons of material into the atmosphere. Much of it escaped into space, dispersing throughout the solar system, but the rest came back. Within hours, this debris re-entered the atmosphere, heating it to temperatures that ignited wildfires across 70% of Earth's forests. The planet burned. And still, the worst was yet to come. The asteroid had struck a sulfur-rich region. When that gypsum vaporized, it injected hundreds of billions of tons of sulfur into the stratosphere. These weren't ordinary clouds. These were stratospheric sulfuric acid aerosols, high-altitude particles that reflected sunlight back into space. NASA scientists estimate the impact generated 35 to 770 billion tons of sulfur. Global temperatures plunged to near freezing. This wasn't a nuclear winter, it was an impact winter, and it lasted for years. Some models suggest a decade or more of freezing darkness. Photosynthesis stopped. For months, maybe years, plants couldn't grow. The food chain collapsed from the bottom up. Herbivores starved first, then the carnivores that hunted them.
75% of all species on Earth died. Ammonites, survivors of every previous mass extinction, finally vanished. Pterosaurs, those magnificent flying reptiles, disappeared forever. Marine reptiles, giant plankton, countless forms of life, erased.
We can see this moment in rocks across the planet. A thin clay layer, rich in iridium, an element rare on Earth, common in asteroids. It's a geological bookmark, a tombstone, 66 million years thick.
But mass extinction is also opportunity. Life at ground zero recovered faster than anyone expected. Within years, microorganisms returned to the Chicxulub crater itself.
Within 30,000 years, a thriving ecosystem had established. The dinosaurs were gone, and in their absence, mammals, small, adaptable, warm-blooded, began to thrive. Without towering predators, without competition for every niche, they diversified. They grew larger. They became whales, bats, primates, us. The Chicxulub impact didn't just end an era, it created the conditions for our era.
The modern rainforest, the Amazon, the Congo, Southeast Asia, was shaped by this extinction. Flowering plants took over from conifers. Forests grew denser, more complex. We are here because of that asteroid, because of that catastrophic, random, universe-altering collision.
Today, NASA and other space agencies map near-Earth objects. We scan the skies for the next Chicxulub. We debate deflection strategies. We plan. But there's another lesson here. The same scientists who modeled the impact winter also modeled nuclear winter. They discovered that even a limited nuclear exchange, far smaller than the Cold War arsenals, could inject enough soot into the stratosphere to block sunlight for years. Crops would fail. Billions would starve.
The Chicxulub asteroid was natural, random, unavoidable. But the threats we face today, climate collapse, nuclear proliferation, ecological destruction, these are choices.
The dinosaurs had no warning, no defense, no chance to prepare. We do. The question isn't whether the universe can end our world in an instant. It can. It has. The question is whether we have the wisdom, the foresight, and the courage to protect the fragile continuity of life that survived that terrible day and evolved into everything we know and love.
66 million years ago, a rock the size of a mountain ended a world. But it also made room for a new one.
The story of Chicxulub isn't just about extinction. It's about resilience, about the thin line between catastrophe and opportunity, about how quickly everything can change, and how sometimes, from the ashes of the old world, something extraordinary can rise.